Welcome students to your chemistry class. In our last class, we looked at naming of alkene, which are hydrocarbons with single bonds. Okay. In today's class, we are giving attention to naming of alkenes, which are hydrocarbons with double bond. Double bonds are otherwise called pi bonds. So let's look at how to name this compound. You have compound like CH3, CH2, double bond, CH3, CH, double bond, CH3. Okay. Now, I told you that in naming alkene, we use number to indicate the position of the double bond. So if you count now, have 1, 2, 3, and 4. So because of 4 carbon atoms is boot, and then because of the double bond is butene. Then the double bond is at carbon 2, so it's 2 butene. That's how we name this guy. The next, look at this one, this compound here. First of all, the number of carbon atoms here is 1, 2, 3, 4, 5. 5 is pent. And then because of the double bond, pentene. Then the carbon atom, the double bond is located at this position. So if you count this way, is carbon 4. But if you count this way, is 1, 2, 3, 4, and 5. So going this way is giving you 1 position. Going this way is 4 position. IUPAC says the lowest possible number. So it will be 1 pentene. But because of the presence of this chlorine, it's an attachment. 1, 2, 3, 4. The chlorine is attached at carbon 4. So we call this 4-chloropentene. Call it 4-chloro-1-pentene. 4-chloro-1-pentene. Or you can also call it 4-chloro-pent-1-ene. So that's how you name that. The next compound is this. Let's count again. Carbon atoms. 1, 2, 3, 4, 5, and 6. 6 carbon atoms is heads. Heads. And because of the presence of double bond, hexane. Now there are various attachments. This is attachment fluorine, bromine, and nitro groups. Okay. So we're going to attach them. Bromine comes before fluorine, before nitro. So bromine is attached at carbon 2, fluorine at carbon 3, and then nitro group at carbon 4. So this, and while the double bond is attached in this place. Okay. So because of the double bond, now we're going to give the double bond the lowest possible number. If you count this way, 1, 2, 3, 4, it's giving it's the double bond at carbon 4. But if you count this way, 1, 2, 3, 4, 5, and 6. It's giving the double bond at carbon 2. So the double bond is a functional group, so we give preference to the double bond. So the nitro group now is at carbon 3, bromine at carbon 5, and fluorine at carbon 4. So the compound will now be named as 5-bromo, 3-fluoro. Is it going this way? 1, 2, 3, 4. Okay, it's 4. 4-fluoro, then 3-nitro, 2-hexene, 2-hexene. That's the name of the compound. It can also be called 5-bromo, 4-fluoro, 3-nitro, hex2-ene. That's how I name the compound. Okay. The next one here is 1, 2, 3, 4, and 5. That is pent. And then because of double bond, pentene. Then there's attachment here. You have to give the double bond the lowest possible number. The double bond lowest possible number. So it will be 2 pentene. And then the iodine is attached at carbon 2. So this will be 2 iodo 2 pentene. 2 pentene. That's how we name this compound. Now look at this one. This one is a condensed one. In inorganic compound, when you have a condensed structure, it's advisable you open the structure. You see, C, open bracket CH3, close bracket 2. It's telling you that this CH3, there are two CH3 attached to this carbon. So if you open this structure, it's going to be like this: CH3, CH2, C. Then this CH3 attached to it up and also attached to it down. You are opening it. Then this CH double bond, CH and then CH what? 3. So how many carbon atoms? 1, 2, 3, 4, 5, and 6. 6 carbon atoms is heads. Then because of double bond is hexene. Okay. Now the attachment is of position 3. And the attachment are the same. I say when you are attaching the same company, we use di and at position 3. So we have that 3, 3 dimethyl hexene. Now take note something that the double bond is at this place. So if you count this way, the double bond is at carbon 4. But if you count this way, 1, 2, 3, 4, 5, and 6. If you go this way, the double bond is at carbon 2. So the double bond is the functional group. So you give preference to the double bond. And that is why this name is wrong. So the correct name will now be going this way, which is 4,4 dimethyl 2-hexene. 2-hexene, giving the lowest possible number to the double bond, and then using di to represent the 2 methyl groups. Finally, this other compound. If this compound here, you need to open it first before you can name it. They are telling you that there are 3 methyl groups attached to this carbon. This one also 3 methyl groups attached to this carbon. So if you open it up now, you're going to have C, this carbon now. Then this CH3, you have CH3 1, CH3 2, CH3 3. So these are the 3 methyl groups attached. Okay. Then this one now, CH2. This one is supposed to be double bond here. CH double bond CH. Then the same thing happens here. This carbon is clustered by 3 methyl groups. 1 methyl, 2 methyls, and then 3 methyl. So when you open it this way, it becomes easier for you to name. Now let's count the carbon atoms. 1, 2, 3, 4, 5, and 6. 6 is heads. And then double bond is in, so hexene. Now the double bond comes at position what? 1, 2, 3. 1, 2, 3. So whichever way you can follow, okay? That is 3 hexene. Now if you observe very well, there are 4 attachments. 1 methyl, 2 methyl, 3 methyl, 4 methyls. And they are all the same thing. So we use tetra to represent them. So that will be 1, 2. 1, 2. That is 2. Sorry, 1, 2, yes, that is 2, 2, because the 2 methyl groups are attached at carbon 2, then this other 1, 2, 3, 4, 5. 2 methyl groups are attached to carbon 5, so 5, 5, then tetramethyl, because there are 4 methyl groups attached to it before you now have your 3 hexene. So that is how you name the alkene. Thank you very much for being to the class. Next time we continue.